Alright, in this section we're going to be looking at complements of the probability of at least. So sometimes when you're trying to solve a particular problem, it's easier to solve for the complement of it and then work our way backwards. So if we're finding the probability that some event will occur at least once, this is what we're looking at, is the complements problem. So here, if you do not get at least one occurrence of event A, then event A did not happen at all. So here we're applying a little bit of logic formula when we're working through this problem. Thus, in a blank number of trials, if at least one event of A occurs, then the complement, or opposite of that, is that event A does not occur at all. Using this logical and statistical formula, we can work backwards and forwards from one to the other. Let's take a look at an example of this. So here we're going to be looking at example number 6. It's on page 172 in your book. And here we're looking at a couple that has 5 children, none of which is a girl. So we want to solve for what is the complement of this particular probability. So here we have the probability of having 5 boys in a row. What will be the complement of that? Now pause the video here and take a moment and go through and write your answer down verbally before we go on to doing our calculations. Again, it's very important to make sure that you understand what you are solving for before you start plugging your numbers together. So pause for a moment as you're working through this problem with me and write down your answer for that, and then move on to the next video page and we'll check it together. Okay, you would have had at least one of the children is a girl. Now notice a complement here is an at least one. It is not the same thing as a direct opposite. A direct opposite would be if you had all 5 children that were girls. So do not mix these two together. What a complement, we're talking about an example of at least one. So if we're looking at our probability calculation for this, if we let A equal none of the 5 children is born a girl, and then we have not A, being that at least one of the 5 children is born a girl, we have our probability formula here at the bottom. And yes, that does look exactly like the formula that we've used previously. So we're using this exact same rule and applying it to a slightly more complicated situation. And remember, all total probabilities equal a probability of 1. So thus we have our 1 is the total area of all possible probabilities. And thus if we have 2 components, if we remove 1, P of A, then whatever we have left is going to be our P of not A. So let's go through and look at how we set this problem up to solve it. So remember, we're setting this problem up to solve for the complement. So we're solving for the opposite of. This means that our first step is solving for P of A. Remember, we're going to plug our P of A into the formula to get our P of not A in a working backwards instead of trying to solve directly for P of A, which would be very difficult here because we've not specified what particular order a girl is born in. So we need to write out the 5 probabilities we are solving for in a statistical formula. So take a moment and write those out yourself as you're working through this problem. And when you're ready, move on to the next slide and we will check them together. Alright, you should have got a P of boy 1, so that's the first child being born a boy. Probability of B2, second child being born a boy, and so forth all the way down for all 5 events. So we have a probability of B1 all the way through probability of B5. Now let's look at the next step of solving this problem. Our next step is calculating out what is the probability of B1. And here, we're again going back and using our basic probability formula. So we've got the number of ways the event can occur, in this case a boy being born, so there's only one. And we have our sample space of all possible events, which here would be a boy or girl. So we have 2 possible ways the child can be born. And so we're taking our number of ways the event can occur, and we're dividing it by the sample space of all possible events. And we're going to repeat that for each of these 5 events because these are not, these are each an independent event. So, take a moment, put all this into a formula, and when you have that written out and organized, move on to the next slide and let's check it together. You should have got something like this. So here we have our probability of B1 times our probability of B2 times our probability of B3 times our probability of B4 times our probability of B5. And of course, then we have plugged in 1 divided by 2 for each of these, which gives us 0.50 for each of the individual births. So, computing those together, timesing each of those by each other, what do you get for our probability of having 5 boys? You should get about 0.031. As you can see, it's kind of an unusual event. So, we're part of the way. And the next step is we just need to apply our complements formula. So using our complements formula for the left and moving it over, let's plug in our 0.031 and solve our formula. So pause the video here, go through and do your calculations, and then when you're ready, turn the video back on so we can check it together. Alright, you should have got something that looks like this. So here we have our P of not A, that is at least one of the 5 children born as a girl. It's going to be equal to 1 minus 0.031, where we've moved that down from, that is our probability of A, or having all 5 children be a boy. And so we get our probability for having at least one of the 5 children born a girl is 0.969.